Hello everyone. Today I will introduce IceBear, a fine-grained incremental schedule for C, C++ static analyzers. Static analyzers are used to detect hidden bugs in early stage. Many C, C++ static analyzers consider single file as an analyze unit, and analyzing each file individually to produce bug reports. But how to analyze an entire repository with these analyzers? Here is an existing workflow for scheduling analyzers to analyze a code repository. First, build the repository and generate a compilation database. This compilation database records all files compiled during the build process, along with their corresponding build commands. Second, schedule the static analyzers to analyze all files recorded in the compilation database and get the bug reports. When modifications are made to the repository, should we reanalyze the entire project? The scheduling tool called Tracker employs an incremental build-based strategy. After modifying the repository, perform an incremental build and record an incremental compilation database. Then only reanalyze the files recorded in this incremental compilation database, thereby achieving file-level incremental analysis. But this strategy can be inefficient in the following regular situations. When a high-level header file changes, all files that depend on it will be recompiled, leading to a large number of files being reanalyzed. What's more, a single file might contain thousands of functions. If only a few functions change, most function analyzed results remain unchanged, making their reanalyze redundant. To improve the efficiency of incremental scheduling further, we have introduced IceBear. IceBear's incremental scheduling strategy is also based on incremental build, but refined it in three ways. First, IceBear does not directly analyze all files in the incremental compilation database. Instead, it processes the files to generate corresponding translation units and compares them with cache to filter out only those files where the translation units have changed. Based on the difference in translation units, IceBear determines affected ST node and functions within the cryptography. When scheduling static analyzers, IceBear analyzes only the affected functions, enabling function-level incremental analysis. During report generation, IceBear only includes reports related to affected node. Now I will demonstrate how to use IceBear to analyze a real-world C project. Assuming that we are working on this project and we are currently at this version. To ensure the project can be built, we first run the config script to generate the makefile. To build this project by IceBear, we pass the build command through the -build parameter. IceBear will automatically build the project and use -o parameter to specify the output directory of IceBear, -j to enable parallel analysis, and -inc to specify the incremental strategy as a function-level incrementer. Then IceBear starts building the project and capture the compilation database. After the build is finished, IceBear then uses Panda to concurrently schedule the analyzers. After the analysis is finished, we can see that a total of 2,000 fields were analyzed, and the total analysis duration for the 3 tours is 800 seconds. In the output directory, we can see a summary of the analysis reports. The analysis generated about 7,000 reports, which is a huge number. A brief version of the report is provided for easier code review, and the detailed version report can be found in the corresponding folders. After the full analysis of the first version, supposing that we made a series of modifications to the project and now at version EECDC2. Now we want to analyze whether our modifications have introduced any new bugs. We use the same commands as before to make IceBear perform an incremental build and the incremental analysis. The incremental analysis is much faster than full analysis, reduced from 800 seconds to 51 seconds. Additionally, the total number of reports generated is also much smaller than before. The reports related to the modification can be found in reports.json, and the new reports can be found in new reports.json. This is the end of the demonstration of IceBear. Thank you for watching.